Greetings, I'm Squared here, and today we're going to talk about solving literal equations, sometimes known as formulas. We're going to get one of the variables alone. Formulas usually have more than one variable. Literal equations, that's what that means. It has more than one variable. So I want you to look at these two things right here. I want you to look at what do you notice? What's the same? What's different? So we see that the 2x is the same, but then instead of a plus 1, I have a plus c, and instead of equals 9, I have equals d. So you see how over here we would call this a literal equation because it has 3 variables, whereas this one we're just going to call a linear equation, has 1 variable. If you know how to solve this, then you know how to solve this. It's just that you got to get your mind away from, hey, there's too many letters. Because if you know that you're supposed to subtract 1 from both sides here to get x alone, then how do you get x alone? Well, we'd start with subtracting c from both sides. So here we get 2x equals 8 because 9 minus 1 is 8. But over here we get 2x equals d minus c because you can't take c away from d. But looks funny, but that's the exact same thing. You do it the exact same way. And now what do I have to do? I have to divide by 2 because that's how I'm going to get rid of the coefficient to get x alone. So my answer here is x equals 4. Over here, when I divide by 2, I get x equals d minus c over 2. I don't know what d minus c is, so that is my answer. So your answers are going to not just be a pretty integer, your answers are going to actually have other letters in them. That's how we do it. So one of the things you'll do is use formulas. So this formula right here, distance equals rate times time, is an important formula. I use it a lot in math. And it helps us find distance if we know the rate and time. It helps us find rate if we know the distance and time. And it helps us find distance if we know the rate. And it helps us find time if we know the distance and the rate. So it's always important to know which one is which. So it says Fran rode her bike 42 miles. That's distance. In 7 hours, that's time. So how fast was she going? That's rate. They're asking me for rate, so I need to take this little distance equals rate times time formula and solve for rate because I need to know the rate. So now I find out that rate is the distance divided by the time. So I look up here and say, well, what was the distance? It was 42 miles. What was the time? It was 7 hours. Well, if I take 42 miles and divide it by 7 hours, I get 6 miles per hour. So that is how fast she was riding her bike, 6 miles per hour. Alrighty, how about this one? If Pedro needs to get to Seattle in 3 hours, how fast does he need to go? Seattle is 203 miles from Richland. Well, here's my distance. Here's my time. I need to know my rate. So I need to solve for rate. We just did that over there. It says how fast, that's rate. So rate equals distance divided by time. So again, I take 203 miles and I divide it by 3 hours. So 3 goes into 26 times with 2 left over. It goes into 23 7 times with 2 left over. So it looks like I would have to average about 67, 68 miles per hour in order to get to Seattle, in order for Pedro to get to Seattle in 3 hours. All right, let's try another one. So here we go. A worker at a framing store is making a rectangular frame. He knows the perimeter of the frame is 144. Perimeter, that's going to be important. The length is 40 inches. How can he determine the width of the frame? Well, who remembers how to find perimeter? Perimeter equals 2 times the length plus 2 times the width. They gave me the length. They're asking me for the width. I've got to solve this for width. So I'm going to subtract 2L from both sides. So P minus 2 lengths equals 2W, and then I'm going to divide by 2. So now I know that W is going to equal perimeter minus 2 lengths, and I know what the length is because they told me. That's 40 inches, over 2. So perimeter was 144. I can put that in 2, 144. So now let's do our math. 144 minus 80, right, divided by 2, because that's 80. So you can get your handy-dandy calculator out and put that all in at once. 144 minus 80. If you don't press equals here, then you're only going to divide the 80 by 2. So make sure you press equals or else use parentheses. Divided by 2. So now we know that our width was 32. So you can always check it, right? What's 32 plus 32? 64. and that's 80. What's 80 plus 64? 8 equals 144. So you can always check it like that if you need to. Okay, here's another one. Fahrenheit and Celsius. So we use Fahrenheit here, but a lot of countries use Celsius. And it says in a recipe that you should put your temperature at 190 Celsius, right? But we need to know the Fahrenheit. So how could we solve this for Fahrenheit so that we could use it every time we needed to? Well, the first thing we would want to do is get rid of this 5/9 because it's being multiplied. We get rid of a 5/9 by multiplying by 9/5. So I'm going to multiply by 9/5. It cancels out here. So I have 9c over 5 equals f minus 32. So then if I just will add 32 to both sides, I get a formula for Fahrenheit, at which point I can put the 190 right there. Now I'm going to get out my calculator. So I'm going to say 9/5 times 190 plus 32, and it's going to tell me 374. And of course, most ovens don't go to 374, so we'd go to 375. But that is how you can solve that little formula for Fahrenheit and then figure it out. Okay, let's just try to solve some plain old equations. So this one, it says get x alone. If I need to get x alone, I have to get rid of this. What's it doing? It's adding. So I have to do the inverse operation. The inverse of adding is subtracting, the opposite. So I get y plus 12, y minus 12, that's my messy handwriting, y minus 12 equals x. So this is my formula solved for x. Over here I'm supposed to solve for m. Remember, first get rid of the multiplication. So I'm going to multiply both sides by 5/4. So I get 5/4 n equals m plus 7. M is almost alone, I just have to get rid of that 7, so it's being added, so I'm going to take 7 away. So m equals 5/4 n minus 7. And now, that's what that equation is right there. We just figured that out. So now it says use it to find out what m is when n is 40. So I'm going to take 40, I'm going to plug it right in there. So m equals 5/4 times 40, because that's what our new n is. So I like to not use a calculator if I don't have to. 4 goes into 40, or if I divided first, that's 10. What's 5 times 10? 50. 50 minus 7 is 43. So I just found m when n was 40. Okay, last problem. Here is a problem about averages. So Bill got scores on quizzes. And notice there's little subscripts to show you like which quiz it is. So there's 3 quizzes. There's quiz 1 plus quiz 2 plus quiz 3. Finding average is when you add them up and you divide by 3 to find the average, right? So this is, write a formula for finding the average of 3 quizzes. That's our formula. We add them up, divide by 3. But then it tells us what he got on the first 2. So he got an 85. So just plug it in the formula. An 88. But we don't know what he got on his last quiz. That's a mystery. So we're going to say plus x. But this is still the formula to find the average. And it says, what formula could Bill use to determine the score he needs to get on his third quiz if he wants to average 90? So what does he want the average to be? He wants it to be 90. So that's when I say equals 90. Then I can, to get x alone, because that's what we're trying to find, that third quiz, I'm going to multiply both sides by 3, because that gets rid of that one. So I have 85 plus 88 plus x equals 270. So now I have to add those 2 together. That gives me 13,173. So I subtract 173 from both sides. And here's where I'll get my calculator out. And you could have just said 270 minus 88 minus 85. You could also have done that too. 97 equals x. So is it possible for him to get an average of 90? Yes. If he does awesome on this quiz and gets a 97, he will end up with a 90 average of those 3 quizzes. All right, that's a little bit about literal equations. Good luck with that. M squared, signing out.